Be asked to find are your principal stresses after you've found the orientation to those principal stress planes. So to do that, you're going to take the formula for your average normal stress, and you're going to take the formula for R, and to get sigma 1, you're going to add those two together. And to get sigma 3, you're going to subtract them. So here I did just that. I did sigma x, remember, was 50, sigma y was 10. So 10 and 50 is 60, divided by 2 is 30. Over here I subtracted them, so I got 40 divided by 2 is 20. 20 squared was 400. And tau was 40, so 40 squared is 1600. I took the square root of 2000, which is those two added together, and I got 44.72. So sigma 1, again, I'm adding these together, and I get 74.72 megapascals. And for sigma 3, I'm subtracting them, and I get negative 14.72 megapascals. And here's an important point. Sigma 3 is negative, and sigma 1 is positive. And so that means when we go to plot this thing on a Mohr diagram, or as a Mohr circle, we should expect it to plot partly in tension and partly in compression. Now, if you remember over here when I drew this, you might have thought, hey, all these arrows go in, so we're always going to be in compression. But the truth is that a Mohr circle just represents a series of combinations of sigma x and sigma y. And so you may have one particular orientation where sigma x and sigma y can both be positive, but for your principal stresses, they're not both positive. Okay, and here this is just slightly negative compared to this being really positive. So let's go ahead and plot this and just see what the circle looks like. So I'm going to go up to my axes, which are of course labeled because that'll be worth some points. And just for now, I'm going to make tick marks that aren't exactly perfect. So 1, 2, 3, 4, 5, 6, 7, 8, and I'll say each one of those tick marks is 10 megapascals. It's really important for you to give that scale. And on the negative side, I'll go 2 down. Okay, so we know that our sigma 1 was 74.72. So I'll come out here and say it's going to plot about right there. And I'll label that sigma 1. And I know that sigma 3 was negative 14.72. That's going to plot about right here. And I'll label that sigma 3. Okay, so now an easy thing to do to be able to plot this Mohr circle all together is to find the center point. So I'm just going to average sigma 1 and sigma 3. So negative 14.72 plus my other one was 74.72. And I'll divide that by 2. Oh, it's 30. That's right, we knew that because we calculated it down here. So I'm going to come over to 30 and put a point. And I'm going to label this a sigma with a little hat, just to show that that's an average. So now what you're going to need to do is use your compass. And so you put your pointy end on your average and stretch the pencil end out until you get to sigma 3. And then go ahead and make your arc. I'm going to set the camera down for just a second. I'll have to cut all this out of the video. Okay. And there it is. You can see I didn't do it perfectly the first time, so I erased and I redid it when it looked right. So that's my Mohr circle. I'm mostly in compression, but I got a little bit in tension. And now I might be asked to find the tau max, which is the maximum shear stress, and the normal stress that's associated with it. And at the surface, this might seem kind of hard, but if you think about this, on this Mohr circle, we know that the y-axis is tau, which is shear stress. So we just got to find the highest point in the y direction on the circle, and it's going to be right here, right? Okay, so whatever value is associated with that part of the circle is going to be our tau max. And we know that any point on the outside of a circle is just the radius of the circle, right? That distance is the radius. So if we go straight up, that distance should be r, and we've already calculated r. We know that r was 44.72 megapascals. Okay? And since that also corresponds to the center of the circle, that means the normal stress that goes with that is just our average stress, which we found to be 30 megapascals. So Mohr circles aren't as hard as you might think. You just need to see the connections between this Mohr circle and this box diagram. Okay, so again, this sigma x and sigma y, those are the plane stresses, because they lie in the x and y plane here in the box diagram. They are not the principal stresses, sigma 1 and sigma 3, but we can use these to find these other stresses. But to get here, you know, it's important to be able to use those 3 formulas we talked about in the beginning of the video and apply those to get to this point. So, thanks for watching.